Okay, here we are. It's kind of that extra chapter section they have at the end. Volume and surface area. We've already kind of done volume, but they're going to give us some volume problems that have fractions involved. So just kind of, we'll see if I can make something that resembles a box of some kind, like a shoebox. And we'll call it a shoebox, and we'll put all the units in inches. Maybe feet. A shoebox is maybe 1/2 foot wide and 7/8 feet long and 5/6 feet tall. So this is like the length, the width, and the height. We have 3 directions, and volume still happens to be base times height, or length times width times height. You have the same formula for volume. And I'm looking real quick at the book to make sure that I'm doing it the same way that they are. And it looks like it. Length times width times height, exactly the same way. And we just have to jump in and go. So volume here equals 7/8 times 1/2 times 5/6. You just simply work through and multiply. Now you can simplify ahead of time if there's anything you can simplify, but I was unfortunate when I chose my numbers here. I've got kind of odd numbers on the top and even numbers on the bottom, and so nothing really simplifies here. 7 times 1 times 5 is 35, and 8 times 2 times 6 is 12 times 8 is 96. I got 12 by multiplying the 6 times 2. 35/96, and it's possible that this would simplify. I'd have to spend a little time working on it, and we're not going to do that because you don't want to watch this video for that long. Say we had different numbers on our box. Maybe some numbers here that we could possibly simplify before we multiply. And so maybe we have 6/8 of a foot long by 1/2 by 4/6 tall. And of course those might be a little too obvious, but if we go through and put them in, 6/8 times 1/2 times 4/6. Okay, so this gives us some things that we can simplify before we multiply. Just looking up here and noticing that this problem looks a little bit like it's missing something. I said that we'd do it in feet, and it's not feet squared, it's feet cubed. So 35/96 of a square. So this is like about half of a cubic foot. It's kind of what we got there. And this particular one is probably going to be even smaller than that. But if I look at it, 6/8 is the same as, let's see, divide by 2, I'd get 3/4. Divide this one by 2, I'd get 2/3. And then this 2 and this 4 could simplify down to 1/2. 2/4 is the same as 1/2. And then it looks like I could simplify this 3 and this 3. I forgot to cross those out. This 3 and this 3 down to 1 and 1. And then when I start to multiply, I've got 1 times 1 times 1. 2 times 2 times 1 is 4. So 1/4 feet cubed. Hopefully that makes sense. I think it does for most of us. And I can't take any more time because we've got to work on an even harder topic here. We're going to talk about surface area. Now if I took my cube, let's use straight lines again. If I took my cube, or my square, or my cubic, a 3-dimensional object, okay, it's shoebox or cardboard box or house, whatever you decide this represents. And we want to lay it out. And they're showing us that what it looks like, you have something that you can't see. You can count 1, 2, 1, 2, 3 of the surfaces. Each of these is a rectangle, but there are 3 surfaces we can't see, and we sort of have to like take the box apart. If we imagine it's a cardboard box, and we drew the bottom like this, the bottom is the side that we can't see. And then we laid this front piece down. We might have to lay it down like this. And then we laid this side piece down. It would come down like this. And if we folded this top, we folded it, let me get you another curved line. If we folded this top this direction, and then this back piece that we can't see, we folded it down, we would end up with having a short one here and a longer one. Oh, we can do better than that up here. I'm looking around. And then there's also a piece on the back that we can't see back here behind everything, and it would get folded out like this. Okay, so we can see that there are 1, 2, 3, 4. Well, let's go ahead and list them. This piece number 2 ends up being over here, and this piece number 1 ends up being right here, and this piece number 3 ends up here. And we can see that we have 3 pieces that we can see, and this shows that there are 3 more that we can't. And this is sort of the one end of the box. This is an end of the box. There's another end of the box on the other side. That kind of goes together. In fact, we might be able to, I suppose, we could just call it 3 because these are the same size. Okay, and the opposite of this front one, the one that's on this back side that we can't see, we can call that 1. And then we have the top, which is number 2, and then there also happens to be a bottom, and they're opposite each other, and they happen to be the same size as well. So it's almost like we have a front, there's a front, a back, and then maybe a right, and then this one here would be a left, and then this here is a top or bottom. I guess this would be the bottom, and this one is the top. So you can see that you've got a front and a back, a top and a bottom, a left and a right, and you can actually see it flattened out like this, or you can see it in the box form. You just can't literally see it. You have to kind of imagine, and sometimes we do that by putting the little dotted lines and connecting them like this. Then you can kind of start to, if you're careful, you can kind of see that there's something hidden behind the box. There's this other side, and that you can't see, but there's 3 sides that you can't see and 3 that you can, for a total of 6 sides. And we start working out the shape. We work out the dimensions, and we're going to find surface area, which is different than volume. For surface area, and we have to just find the area. Okay, and remember, the area equals length times width. So we're going to do it for all 6 of the sides, and I suppose it might be that we redraw our rectangle. It would be nice, maybe, if I drew at least one piece of it that's really straight. And then since these have to be angular, it's impossible to do them perfectly straight just by eye. And I don't want to go so slow that you get bored watching. Okay, so this is sort of a little cleaner version of this one. We're going to imagine that they're the same. And we might call this like 6 inches, and this 3 inches, and then this 4 inches. Alright, so if this is 6 inches and this is 4 inches, this is that front piece. We had one front and one back, so we have front is 6 by 4. 6 by 4. Back is the same. Okay, and then this top is 3 inches this way and 6 inches this way. So we have top is 3 by 6 or 6 by 3, and bottom is the same. And then we have a left and a right. And this is where it gets kind of crazy. 3 times 4, 3 by 4. And the right is 3 by 4, and the left is 3 by 4. Or this right and this left here. We've got this whole set. And we have to find the surface area by finding all of the areas, all 6 areas, 1, 2, 3, 4, 5, 6. There's 6 sides, and basically adding them together. And it shows you how to do this in the book. Just going to put all our answers in. 6 times 4, and again 24. Ooh, I said 24, but I wrote 26. And then 18, and again 18. And then 12, and again 12. And then you have to just add them all up. Now, you could do this a number of ways. I know a lot of students that like to double things, so they might just go, well, this is 48, and these two are 36, and these two are 24, and then you could just add them together, and or you might actually just add these two together. 30 plus 20 is 50, and 6 and 4 is 10, so you'd end up with 60 plus 48, and then it just ends up being 108. 8 plus 0 and 6 plus 4 is 10, or you have to carry that over, 108. Makes sense, right? Hopefully. And since we did inches, it ends up being inches squared. Kind of cool. That's how that works. That's surface area of they call it a rectangular prism. Okay, a prism just shows that it has a rectangular at one end and it goes for some distance, which just means it's three-dimensional. If you really want to take prism to the nth degree, you show something long like this. It's this shape at one end and it just gets stretched. We're going to move on next to like triangular prisms, and they're the similar kind of thing, but they're like a triangle that gets stretched all the way out in like a prism. And then we're going to come to a new page, and we'll draw real quickly a triangle. Looks just like maybe like a little pup tent. You go camping and you get this little pup tent thing, and it's kind of like a triangular prism. I can do a better job than that. There we go. All right, so there are 2 sides that we can see. There's this front, and we know there's also a back. And we can kind of imagine that this edge here houses a bottom, and the bottom is going to be a rectangular shape. And so there's a bottom. Now there's not a top. Okay, but there is kind of this side here that's also a rectangle shape, and then there's another side on the other side that's the same rectangle shape, and we could call this like the right and the left. The right and the left. You can almost see that other side. So we have the right and the left. I guess I could actually spell it out. And if we were to unfold it, I suppose what it would look like, you'd have this bottom edge, and then the left edge would get laid down flat, and the right edge would get laid down flat, and then you would be left with these little triangular pieces that get laid down flat. And I suppose this is kind of what this shape would look like if you unfolded it. And I think if you spend a minute, you can think about how that might work. We can work on this one. We might say that this is 3 inches and this is 10 inches. And so if this is 10 inches and this is 3 inches, we will have to find out our height. And to do a triangle, we have to know the height. And I think that usually they do that. I'm kind of checking in your book. It looks like I skipped a page. Yeah, they're going to give you a height for sure. So we're going to call this 4 inches high. So the height is 4 inches. The base is 3 inches. And then the prism itself has 3 rectangles that are all exactly the same, because this triangle happens to be 3 by 3 by 3. All sides of the triangle. It's an equilateral triangle. So we have 3 all the way around. Okay, so we can make that work. That means that all of these rectangles are 3 by 10. And the one in the middle here is 3 by 10 as well. So we have the front, back are triangles, and then the bottom, right, and left happen to all be exactly the same. They all happen to be, let's change colors here to keep it interesting. The bottom is 3 by 10, which is 30. The right is 3 by 10, which is 30, and the left is 3 by 10. Now it's these front ones that we have to kind of work at. Remember that an area of a triangle is 1/2 base times height, and the base is 3, so it's 1/2 times 3, and the height is 4. And 1/2 times 4 is 2, 2 times 3 is 6, so it's 6 inches squared for the front. I guess we could put that formula in here, 1/2 times 3 times 4, and the back is the same thing. And then we get all of our answers. So we have 6 inches, 6 inches, 10 inches, 10 inches, 10 square, and these are all square inches. So this is 10, 20, 30. These two go together to make 12. So 30 plus 12 equals 42. So it should add up to 42 inches squared. I know I kind of zipped through that right at the end, but I know that I promise you guys that I try not to put real long videos together, and this is probably closing on longer than what I want. So work through that and have fun with this assignment.